Different types of scheme are available and here are some of them. I'm going to explain them briefly one by one. MIT scheme. MIT scheme is a complete implementation of R4RS scheme including a native code compiler and integrated Emacs-like text editor. The compiler produces good but not outstanding code. The editor is a clone of GNU Emacs 18 with some Emacs 19 features, except that it is programmed and customized in Scheme rather than in Emacs Lisp. The tools form a complete programming environment. MIT Scheme is an industrial strength implementation featuring a rich runtime library, integrated source-level debugging, portable 2D graphics, and extensive I/O capabilities. It is one of the oldest Scheme implementations and is consequently fairly stable and debugged. It is the implementation that MIT uses for teaching structure and interpretation of computer programs. Big Blue is another type of scheme. Big Blue is a scheme system devoted to one goal, that is enabling scheme-based programming style where C++ is usually required. Big Blue attempts to make scheme practical by offering features usual to traditional programming languages but unusual to scheme and functional programming. Big Blue is an extended foreign interface, an object-oriented system, a batch compiler, an explicit type system and compile time type mismatch detections, simple exceptions, practical IOs by the means of lexing and parsing tools. Let's see another type of scheme. Doctor scheme. Doctor scheme is a graphical environment for developing programs using the Scheme, MEZ scheme, and MRED programming languages. Doctor scheme's features include source text highlighting of syntax errors and runtime errors, support for multiple levels of scheme from beginning student to full scheme, an algebraic stepper for beginning student language, interactive and graphical static analysis, a graphical user interface library. Objects, threads, modules, exception, TCP/IP and regular expression, and file system support. Q-scheme is another type of scheme. Q-scheme is a fast and small implementation of scheme written in C. Q-scheme is easy to interface and should be easy to use as an extension language. Q-scheme currently supports foreign function call and dynamic library. A Perl-like regular expression module is provided as example. Q-scheme is really fast. Benchmarks shows that it is generally between 2 and 70 times faster than other scheme interpreters. Lisp. Lisp is a lightweight scheme interpreter on Caffeine. It is smaller scheme interpreter written in Java. Lisp provides arbitrary precision numbers, rational and complex number support, first-class environments, environment relative addressing, first-class errors, data triggers, dynamic module support, and soon will use FCEs to provide object orientation.
The best way to get started with Scheme is by playing around with it. This will show you what you are able to do with Scheme as a language. By typing this, you can work with Scheme. Syntax. The Scheme syntax is extremely simple. It consists of parentheses and prefix notation. This means that the operator comes leftmost followed by the operand. For example, you can take this. Parentheses are used to define what is to be computed. In many languages, it is possible to add extra parentheses without affecting the program, but this is not the case in Scheme. Adding extra parentheses will most likely to result in errors or other unfortunate behaviors. Expressions. There are two types of expressions, primitive and derived. First, we will consider primitive. Primitive expressions are, for example, variable references, literal expressions, assignments, and so on. An expression consisting of a variable is a variable reference. For example, you can take this. Literal expressions are expressions created using quote, which are equivalent. For example, something like this. Numbers, characters, strings, and booleans need not to be quoted since they evaluate to themselves. Primitive conditional expressions are constructed using if. For example, you can take this example. Procedures are created using lambda and called by enclosing in parentheses expressions for the procedure to be called and the arguments to be passed to it. This is how we can create a procedure. Derived expressions are expressions that are implemented in terms of other expressions instead of being implemented directly. Conditionals using cond and let expressions are examples of derived expressions. Derived expressions can be defined as macros. Conditional using cond can be constructed using nested if expression. The let expressions could be rewritten using lambda. For example, you can take this. This will be equivalent to the lambda shown in here. Define. Define is used to bind a name to a computational object. The syntax of the define expression is as follows. Define var expression. The expression part is evaluated and the value is then bounded to the variable var. A variable is a symbol to which a value can be assigned, and this variable is then said to be bound to the given value. Let's start with a simple example. Define A2. The third expression is evaluated and has in this case the value of 2. This value is then bound to the symbol A. We can now use the variable in other expressions. These 2 will come here and 2 plus 3 will be 5. The syntax for procedure definition is define name formal parameters body. For example, let us create a procedure square which takes one argument and returns its square. Square is the name of the procedure definition in the environment. X is the formal parameter and multiple signature XX is the body of the procedure. When the procedure is called, for an example square 8, x will be replaced with 8 and the value of the expression becomes 64 and it will return it. The define can be conveniently used to declare global variables and to name procedures. It is a simple but strong means of abstraction. However, it should never be used to define local variables.